Hello, ladies and gentlemen. Welcome back to Math 20-2, Chapter 6, Lesson 2, Properties of Graphs of Quadratic Functions, Part 3. Anyway, Part 2, I forget. So, what I want to talk about here, or just a reminder, y-intercept is the constant term in the equation or the table of values when x equals 0. We just did that graph there. When x is 0, y is minus 2, or we look at the equation x squared plus x minus 2. Now the x-intercept, as I just showed you, we have to calculate the zeros. Now sometimes in table of values, they're really nice. When y is 0, x is 1, and y is 0, x is minus 2. That's our two x-intercepts. Now sometimes we have to calculate them, as I said. I just did one, now I'll do the other. Second, calculate the 0. So I'm doing the x equals minus 2, so I scroll to the left of x equals minus 2. Then the right boundary, I scroll to the right. It's guessing, and then it goes x, 0, x equals minus 2, y equals 0, enter. All right? Now, note there can be 0, 1, or 2 x-intercepts. Sorry, 1, 2, or 0. Now, by that I mean, if you look at the graph, this equation has one x-intercept that touches once. This equation has 2 because it touches twice. And this equation doesn't touch at all, so there's no x-intercepts. Okay. And to remind you of definitions, domain, all possible x values. So x is all real in quadratics. And this is how we say x is all real numbers. XER. That's a fancy way of saying we can plug in any x value we want and it'll work. Now, the range are all possible y values. Either y is greater than something or y is less than something, depending on the maximum or minimum. That is, we have a maximum when a is negative, it will open down. We have a maximum, so y is less than something. Or we have a minimum, that is, a is a positive value. We have a smiley face. We have a minimum. Y is greater than or equal to that value. Okay? So that's what you need to know. So let's do some graphing. See if you guys got this. So next question. A skier's jump was recorded in frame-by-frame analysis and placed in one picture as shown. The skier's coach used the picture to determine the quadratic function that relates the skier's height above the ground, y, measured in meters to the time x in seconds the skier was in the air. The coach came up with the equation y equals minus 4.9x squared plus 15x plus 1. I want you guys to graph the function, determine the skier's maximum height to the nearest tenth of a meter, and state the range of the function for this context. So, I'm going to pause the recording. I want you guys to graph this. We'll come back and compare results, okay? So, graph it, find maximum height, and state the range, the y values. All right? Welcome back. Now, by now, you should be able to graph this and tell me the vertex. So the maximum height I got is 1.5 at 1.5 seconds and 12.5 meters. Now, it's actually 12.47, but I said to the nearest tenth, so rounding off one decimal place. That you all should be able to do. Okay? Now, if you got a problem with that, watch the previous part of the video again, or the previous video, I should say. Now, the question is, the one thing is the range. Now, that's the y values. So, remember, you would stop when height is 0. So, you start here at 0 seconds, and then you go to whatever this time is. Oh, sorry, range is y values, I'm sorry. Range is height. Sorry, getting ahead of myself. So range, y is greater than or equal to 0, and it's less than or equal to 12.5, your y values. That's how high the skier gets. Okay? So far, so good? Good. Now, on the next day of training, the coach asked the skier to increase his speed before taking the same jump. At the end of the day, the coach analyzed the results and determined the equation that models the skier's best jump, y equals minus 4.9x squared plus 20x plus 1. How much higher did the skier go in this jump? Well, let's graph it. Now, what I'm going to do is I'm going to go y2. I'm not going to erase this, the original function, negative 4.9x squared plus 20x plus 1. Graph. Now, you'll notice here, oh, went higher and went farther. Now, excuse me, how do I change my windows? I've talked about this before. I can guess. I'm gonna guess this time. I'm gonna go table set. No, sorry. Windows. The maximum of 20 for y. See what happens. There's my first jump, or the skier's first jump. There's this. Ooh, not high enough. Now, I can guess again, or I can go to table of values. Now notice I scroll over to the second. That's my second table. And I scroll down. I'm getting 21.4 here. So I'm definitely getting above 20. 21.4, that's fairly, so I don't know. So I'm going to go 25. Now there's my first, now there's, not my, the skier's first jump. There's the skier's second jump. So how much higher did the skier go? Well, second, calculate maximum. And notice we're on the first equation here because Mr. Graphing Calculator defaults to the first one. So I need to go to the second one. Scroll up, hit Y2. Now, depending on which version of the Graphing Calculator you have, you might not be able to do that. You might have to go back and erase Y1. It happens. Anyway, so go to the, I scroll up, then if I go down, up, down, I go to the other equation. So I go up and I scroll over. Oh no, I don't want the freaking toggle button. I'll do that in front of me. All right, there we go. Enter to the left. I want to get a maximum height at 2.04 seconds. I'm at 21.4. Now the previous equation was, I forget, 1.5 and 12.5. So the question was, how much higher? Well, what's this difference in height? Well, that's 21.4 minus 12.5. And 21.4 minus 12.5, 8.9 meters higher. That's what I need you to be able to do. Graph on a graphing calculator, domain and range, vertex, answer some questions. Okay? So that's what I need you to know and be able to do. And if I give you data points, you can plug it in and come up with the equation. So the key idea here, a parabola is defined by the equation y equals ax squared plus bx plus c has the following characteristics. If the parabola opens down, a is 0 or negative, the vertex of the parabola is the point with the greatest y coordinate, the height, the top point. The y coordinate of the vertex is the maximum value, maximum of the function. If the parabola opens up, a is greater than 0 or positive, the vertex of the parabola is the point with the least y coordinate. The y coordinate of the vertex is the minimum value of the function. Least. Okay, so negative, maximum, least. The parabola is symmetrical, around a vertical line the axis of symmetry through the vertex. Axis of symmetry. So here's a couple of graphs here. You can see the vertex, minimum value, and the axis of symmetry straight up and down. And it's not a coincidence the vertex is on the axis of symmetry. So if you can find the vertex, you know the axis of symmetry. If you find the axis of symmetry, you can find the vertex. Okay? Not a coincidence. Now, what you need to know, for all quadratic functions, the domain is the set of real numbers, just real, as opposed to imaginary, and the range is the subset of real numbers. Because y is always greater than, so remember what I said? A is positive, it opens up. Y is greater than or equal to something. If A is negative, it opens down, a frowny face. Y will be less than or equal to something because there's a maximum, as opposed to the minimum here. Now, when a problem can be modeled by a quadratic function, the domain and range of the function may need to be restricted to values that have meaning in the context of the problem. That is, we just did that height, the ski jumper. We don't care about height less than 0. All right? Or we don't care about time less than 0. And we don't care about time after they hit the ground. All right? So, if you got questions, shoot me an email. Otherwise, good luck. Go do the classwork.